In May 2018, a paper was published in a journal run by one of the most respected scientific publishers in the world. It did not make any headlines, no breaking news, no viral moments, nothing. But the paper consisted of a very strange case study of a single patient. And the result was so concerning that it should have gotten way more attention than it actually did. A woman arrived at a hospital in San Francisco. She was in her 50s, late-stage breast cancer, and her lungs were already filling with fluid. Doctors examined her, ran her vitals, ordered the scans, and then, like they do for every admitted patient, they ran her numbers through the hospital's early warning system that is supported by the human expertise of the attending doctors. Now, this early warning system gives a mortality risk score to every admitted patient. It basically calculates that score based on standard clinical measurements, things like blood pressure, heart rate, and oxygen levels, combined with the judgment of the attending doctor. For this particular woman, the system gave a mortality risk score of 9.3%, meaning a 9.3% chance of dying during this hospital stay. Now, this number was concerning, but it was not that alarming. It was under 10%, and the system flagged nothing critical. Hence, the doctors moved on to the next patient. But in the background, something else was also happening. A second system was also looking at the woman's file. Not a doctor, not a nurse, but an AI algorithm built by a team at Google. It wasn't just reading her vitals. It wasn't just reading her scans. It was reading her entire medical record. Everything. Old handwritten doctor's notes, PDF reports, and medication histories from years ago. Lab results going back to a full decade. Every piece of medical data ever recorded about this woman. And when it finished reading all of it, it came back with a shocking number, 19.9%, more than double what the hospital estimated. The woman died 10 days later. The hospital system did not see it coming, but the AI algorithm, which was trained on hundreds of thousands of patient records, did. So I want to ask you something. If a machine could predict the day you die, would you want to know? Decades, when a patient was admitted to a hospital, their risk of sudden decline or mortality was calculated using a highly structured and traditional approach known as an early warning system. Doctors would manually input a curated set of standard clinical measurements into the hospital's system. Things like blood pressure, heart rate, temperature, and recent lab results. Because this model evaluated standard and obvious biological indicators, doctors trusted it. It made sense to the human mind that if a heart rate spiked, the risk score went up. They knew exactly why the system flagged a patient. Up until recently, this traditional clinical model was the undisputed gold standard in medicine for predicting patient mortality. But in May 2018, that standard was completely upended. A landmark study was published in NPJ Digital Medicine, a journal run by Nature, one of the most respected scientific publishers in the world. Now, this study was not a thought experiment. It was a massive, real-world undertaking by Google's medical brain team, working in partnership with researchers from the University of Chicago and UC San Francisco. They were building a deep learning AI algorithm capable of predicting critical medical outcomes, including mortality, with a precision no clinical model had achieved before. And the approach was radically different. Instead of asking doctors to fill out forms with a handful of traditionally selected biological indicators, Google asked a deceptively simple question. What if we just gave the algorithm everything? They granted their AI direct access to the raw, messy, unstructured data inside a hospital's electronic health record systems. Not a traditionally curated input, but everything. Digitized handwritten doctor's notes from years past, old medication lists buried in unread PDFs, decades of historical lab values, and vital signs scattered across multiple hospital visits. The scale of the data was staggering. The model was tested on more than 200,000 adult patients across 2 major US academic medical centers. In total, the algorithm processed over 46 billion data points across all those patient records. Now, to put that in context, the individual case study patient that we saw at the start of the video, her record alone contained more than 175,000 data points. When the results came back, the medical world was forced to pay attention. The hospital's traditional, highly trusted early warning system, based on the statistical measure of AUROC, accurately separated the patients who were going to die from the patients who were going to survive 85% of the time. But the Google's AI algorithm did it 95% of the time. A 10% difference might sound like a mere statistical bump, right? But in a hospital setting, it is monumental. That margin is literally the difference between catching a patient hours before they collapse and missing their decline entirely. In medicine, a 10% leap in predictive accuracy is directly measured in human lives. But buried deep inside this incredible result was a very uncomfortable truth. How exactly did the algorithm arrive at this highly impressive 95% score? When researchers examined what the AI was actually paying attention to, they found something deeply unexpected. The algorithm wasn't just prioritizing obvious medical emergencies, but it was finding hidden signals and patterns in places no human doctor would ever think to look. It was examining administrative records, things like the exact number of times a patient had been readmitted. It was even checking a random note scribbled by a nurse about the patient's condition 3 years earlier. Information that had never in the history of medicine been part of a clinical risk model. And here is the unsettling part. Nobody, not the doctors and not even the Google researchers who built it, could fully explain why the model weighted these specific factors the way it did. The AI was producing the right answer through a maze of internal logic that human minds simply couldn't trace. This is what the AI researchers call the black box problem. The algorithm works, we just can't always explain how. We might never know exactly which thread the algorithm pulled to find these hidden patterns and signals of life and death. But even if we can't trace the exact steps, we do know the foundation that made it possible. It all comes down to a neural network. To understand how the AI algorithm was, exactly able to make sense of these 46 billion data points, let us break down the working of a neural network step by step. A neural network is not a synthetic brain. It has no medical intuition, no empathy, and it doesn't think. To understand what it actually does, let us start with an analogy. Imagine a junior medical doctor on her very first day as a practicing professional in the hospital. You hand her a patient's medical file and ask her to predict if the patient will survive or die. Now, this is the very first time she's making a critical decision like this. Hence, based on her intuition, she might just guess the outcome at first. But then, her guess is maybe wrong. You tell her the actual outcome, and then she makes a mental adjustment to realize this pattern. You hand her another file, she again guesses, she fails, and then she adjusts again. Now imagine she repeats this exact loop 100,000 times. By the end, she's not guessing. She has unconsciously internalized the hidden connections. She knows exactly which combinations of data points lead to life and which lead to death. A neural network does exactly this. But unlike a human, it never gets tired, it never forgets an important pattern, and it can process millions of variables simultaneously. To get a clear picture of how AI learns, we need to look at the similar kind of data Google's AI algorithm was actually reading. Up on the screen is a clinical dataset tracking 10 different patients. On the left, we have the input variables, things like age, number of times the patient was readmitted, dropping blood sodium, oxygen levels, lactate, which acts as a cellular panic button for body stress, and whether a nurse flagged any cognitive decline earlier. On the far right is the ultimate truth, the final patient outcome. Let us look at how the AI model connects the dots between the two. If you look closely, a pattern starts to emerge. It's not just about age, it's a hidden combination. For example, a spike in lactate combined with dropping oxygen and a cognitive flag along with multiple hospital readmissions often lead to death. This is exactly what the neural network is built to find. Now, this tiny dataset is just a simple example for our understanding. In the real world, a neural network does this exact same thing, but on a massive scale. It smartly connects the dots across millions of data points to find complex invisible patterns that no human mind could ever track. Let us try to understand the architecture of a neural network. Structurally, a neural network processes this data through 3 different stages. First one is the input layer. Every column in our table becomes an entry point called as a node. Age gets a node, lactate gets a node, oxygen gets a node, and likewise every other input gets a node. Next we have is the hidden layer. The data flows forward into what researchers call the black box. Here, the network doesn't just look at lactate alone. Evaluates lactate against oxygen, against readmissions, against the cognitive flag, all at once. It's basically asking one question: does this specific combination of signals mean something? And lastly, we have the output layer. Here, all the mathematics converges on a single final node. It produces one number, and that is the probability of mortality. But then how does the network actually learn anything? Let us try to understand the engine that facilitates this learning to happen. It all comes down to something called as weights. Think of a weight like the volume dial on a stereo. A high weight means the network turns the volume up on that data point, meaning it matters a lot. A low weight means it turns the volume down, meaning it's less important right now. Let's watch it learn using the data points of patient number 3 from our dataset. The untrained network just simply goes through the data. Age 72, lactate 5.5, oxygen 89%. Now because it has not learned anything yet, its weights are completely random, and hence it predicts a low mortality risk score of 15%. Then it checks the far right column. Outcome? The patient actually died. Now the network knows it was catastrophically wrong. So here is where the learning happens. The network sends a mathematical signal backward through its own layers, a process called as backpropagation. It basically asks, which parameters did I get wrong? It then realizes it ignored the lactate spike, total number of readmissions, and most importantly, a nurse had flagged the patient earlier. So it turns the weight up on all these factors and turns the weight down on age, which wasn't much decisive here. Then it does the same procedure for rest of the patients. Guess, check, adjust. Guess, check, adjust. Over hundreds of thousands of rows, the weights become hyper-tuned. The network gets incrementally more accurate, more precisely tuned to the patterns that separate survival from death. After hundreds of thousands of rows passed through the model, the network extracts a profound medical truth without a human ever teaching it. And here's where predictive modeling gets genuinely interesting and genuinely unsettling. The algorithm doesn't just find the obvious correlations like age, severity of disease, which organ system is failing, etc. Instead, it finds non-linear interactions buried so deep in high-dimensional data that no human analyst would ever isolate them manually. It discovers a highly specific multi-dimensional killer. Patterns like, say, a patient who was readmitted more than 3 times in 18 months, whose serum sodium dropped by a specific magnitude during the second week, and whose clinical notes from a prior visit contained language patterns associated with cognitive decline. That combination across all 3 dimensions simultaneously carries a mortality signal that none of those factors carry individually. This particular pattern and the weights for this exact combination are now turned up to maximum by the neural network. And the model now recognizes that this pattern often leads to death. None of these factors alone is a death sentence, but together across all 4 dimensions simultaneously, this combination carries a mortality signal that none of them carry individually. The network has now memorized this pattern, and every future patient will be evaluated against it. This is the fundamental power of deep learning. It doesn't evaluate variables one at a time. It evaluates variables together across time, across visits, across an entire medical history, and finds structure in the interactions that a traditional clinical model simply misses. When the training gets completed, the weights are locked. And now, a brand new patient, someone the network has never seen before, walks into the hospital. Their data is instantly fed into the input layer. The model reads their full record, runs it through every pattern it has learned in the past, and as a result, the hidden layers immediately recognize the underlying pattern of human decline it had memorized during training. By mapping this new data with the smart patterns that are already memorized, the network instantly calculates how closely this new patient data aligns with the past cases of death. And based on that, it gives an incredibly precise real-time mortality risk score, or in other words, a probability. Now, the AI model is not saying that since this patient has a high mortality risk score, hence this patient will die. No, it is never a certainty. It is a probability. The AI model is just simply indicating to us that based on everything that I have seen before, Here is the likelihood. Think of it like a weather forecast. The model doesn't exactly tell you that it will rain, but it tells you that there's maybe a 73% chance of raining, because this exact configuration of humidity, pressure systems, and temperature has historically resulted in rainfall. The exact same logic applies here. And here is the critical thing to understand about its limitations, because being honest about it matters. The model has no understanding of death, no concept of suffering. It has no awareness of what it means to lose someone. It feels nothing. It cannot think. It knows nothing in a way that we know things. It is just a statistical function that is extremely sophisticated, operating over a massive complex input space. But at its core, it is finding which configuration of numbers have historically preceded a particular outcome and applying that mapping to new data. What makes it powerful and what makes it unsettling is that the configuration that it recognizes are the ones we as humans never could. The AI did not outsmart the doctors with medical wisdom. It just outperformed them with the sheer tireless power of multidimensional mathematics. Let's fast forward to December 2023. This is where our story shifts from advanced hospital technology into something entirely different and honestly, fundamentally more unsettling. A team of researchers from Denmark and the US published a study in Nature Computational Science, one of the most prestigious peer-reviewed journals in the world. They had developed an AI system called as Life2Vec. Now, the previous model we looked at, Google's medical brain, focused entirely on clinical data. It analyzed hospital records, lab results, vitals, doctor's notes, etc. They were tools built inside the healthcare system for the healthcare system. But then, what's so different about Life2Vec? Well, Life2Vec is something truly fascinating. It doesn't just look at your medical records or what your doctor said about your health. Instead, it looks at the entire fabric of your existence. Yes, you heard me right. It analyzes your entire life history. To build this model, the researchers were granted access to the national government registries of Denmark. This consisted deeply detailed anonymized records of 6 million Danish citizens, tracking their lives day by day over a 12-year period. The AI wasn't just reading medical charts now. It swallowed everything. Your income year by year, your job titles, how many hours you worked, whether you got married, got divorced, or moved to a new city, your educational history, your mental health interactions and healthcare visits, all of it layered directly on top of your financial and social standing. For 6 million people, the AI was literally trained on a decade's worth of human experience to understand the dynamic patterns of human life. Think about how language works. If I say, it is raining outside, so I will open my, well, you instantly know the next word is umbrella. You know this because you understand the grammar and patterns of language. Life2Vec learned the grammar of a human life. By reading the sequence of a person's past life events, the AI learned to predict the next logical event of the person's life. And here is the most shocking part. After analyzing millions of life experiences, the model was challenged with the most consequential prediction of all: whether a person would die within the next 4 years. The AI was 78% accurate. Yes, let that sink in. 78% accuracy of predicting human mortality just by reading and analyzing your life stories. The model literally learned how human life stories usually end by aligning the new data against millions of similar life experiences and similar patterns it had already memorized. These results completely shattered and outperformed every existing mortality prediction model by at least 11%. Let me give you a concrete example of what the model was seeing. Imagine it reads this timeline. In 2016, a person takes a highly stressful manual labor job. In 2018, their income drops. In 2019, they go through a divorce. In 2020, they miss a routine medical health checkup and are prescribed anti-anxiety medication. Now, to a human reading these government files, these are just unfortunate isolated events sitting in different filing cabinets. But to Life2Vec,
That is a perfectly structured pattern. And because the algorithm has read millions of sequences exactly like it, it knows statistically how this life story tends to end. When asked to predict the next event in that sequence, it calculates the precise mathematical probability of a severe health collapse. Scary, right?
But when researchers looked inside the system to see why it was so accurate, the results were sobering. The strongest predictors of early death were not just cancer or heart disease. The AI placed immense mathematical weight on having a low income, or carrying a mental health diagnosis, or even being a male. The machine proved something that we often ignore. Your paycheck, your psychological state, your social standing are just as predictive of your mortality as your biology.
The chilling accuracy of this model sent ripples across the world. Because of the severe ethical implications of a machine that can calculate when a person might die, the researchers deliberately kept the model locked away. It is not public. But the internet's curiosity was already unleashed. Within days, scammers flooded the web with fake AI death calculators, forcing the research team to issue urgent public safety warnings.
We've now looked at two different studies and two different AI systems. They both used different data and had vastly different ambitions, but they both arrived at the exact same conclusion.
AI can predict the likelihood of human death with dramatic mathematical precision. And it is only getting better.
But technology like this doesn't stay locked in a laboratory forever. It will enter the real world. And when it does, it will create situations that our laws and our human instincts are simply not prepared for. I have 3 questions to ask you, and the third one is the most personal.
First question: how does this change the doctor-patient relationship? Medicine has always been deeply human. It strongly relies on a healer's intuition and empathy. But what happens when an algorithm spots a complex pattern that the human eye simply can't see? How does a doctor communicate a machine's mathematical prediction to a patient in a way that is both comforting and honest? A machine can process the data, but it cannot hold a patient's hand. It cannot offer comfort or empathy or genuine human connection. We are human beings. We all have emotional needs. The challenge going forward isn't about AI replacing doctors. It's about how we preserve the quiet, deeply human moments that actually heal us as machines are doing the heavy lifting in the background. It's about making sure technology gives doctors more time to be human and not less. Second question: how do we balance innovation with the right to privacy? Models like Life2Vec show us that our income, our job history, and the quiet events of our everyday lives paint a highly predictable picture of our future. But achieving that predictive power requires analyzing massive amounts of deeply personal data. As this technology evolves, society will have to decide where to draw the line. How do we harness the benefits of predicting public health trends while protecting a person's fundamental right to keep their life story private? It is a conversation about building the right ethical guardrails today before the technology outpaces our readiness tomorrow.
And that brings me to the third question, the most personal one of all. If an AI model could tell you today with 78% mathematical precision exactly how many years you have left, would you actually want to know? If your answer is yes, what would you do differently today? Is there a passion that you would finally pursue, or is there a relationship that you would instantly mend? And if your answer is no, sit with that for a moment. Is it because you prefer the beauty of the unknown? Or is it because deep down you suspect that knowing the timeline would not actually change how you choose to live your life? Well, both answers reveal something profound about how we value our time. The only difference is, for the first time in human history, this question is no longer a science fiction. The technology is already here. The ethics are still loading. If this made you think, share it with someone who should be thinking about it too. And with that being said, stay curious and I'll see you on the next one.